So in this video, I'll be going into some basics of introductory high poly modeling hard surface props for games. You'll be working on this knife, and you'll be using all of the exact same tools and techniques that I use to work on my firearms, including this Spaz 12 shotgun, a Webley revolver, and a Remington 700 tactical that I've been modeling recently. We're going to start with some basic theory, like describing different methods of high poly modeling for hard surface techniques specifically, and then we're going to get into the demonstration of making that hard surface knife you saw at the start.
Alright, so I just wanted to create like an introductory video on some simple hard surface techniques and fundamentals using Blender, and I'm not going to be using like any add-ons or anything like that, so this is pretty much stock standard Blender, and I wanted to talk first a little bit about the theory and like the basic sort of how you would create certain geometries for hard surface props, and then I'm going to get into working on a tactical looking Bowie knife kind of thing. So something like this kind of a knife is there's a lot of different ways you could approach something like this, and the blade, the blade and the handle and the screws, like they all kind of represent sort of different like ways that I would approach making a hard surface prop like this. So yeah, lots to learn, and then we'll just get into it then. So if I could add, for example, let's say a cube, right, to the scene, and then I'll add another cube, and I'm just gonna bevel this, and I'm gonna give it a bunch of segments. Whoops, smooth shade it. Actually, I'll go down to harden geometry, harden normal, sorry. And we'll say this bevel's like, you know, a couple millimeters versus sort of this cube on the left, right? And if I put this in render mode and we chuck in a sunlight kind of this way, and then maybe like an area light, you're going to start to see like the edges of these cubes, and how on one side it looks very fake and CG, and on the other side it just looks like nicer, looks more real, right? That's sort of the art of hard surface. Do you see this here? This is what we want. So the cube on the left is like, this is a CG cube, right? It's the edges are like very, very chiseled, super mathematically, super clean. And this cube on the right, it's just got like more character to it, right? Like this looks almost like a machined block of aluminum. So that's sort of the point of like hard surface, is to give us control of like these edges, these chamfers or bevels, and to get them to feel like more natural, more real. And then we want to transfer this through like a normal map into like a low poly or lower poly, shall we say, representation of that like high poly object. And even if we're not necessarily going to like bake and transfer, we still want to achieve these like smooth, like chamfered edges, right? So that's sort of the point like behind high poly, behind hard surfacing and hard surface modeling, is to achieve this look on the right. So how do we do this? Well, there's a number of ways that we can do this, right? So I just showed you one, and I'll wrap back around to that, but we'll start with sort of one of the most fundamental, one of the most like standard techniques and oldest. If I run a subdivision through this and just drag this up, so we've got a bit of like a triangle thing going on here, and I add a subdivision surface modifier, and I add that bad boy, and then we just crank the levels a few times. What we can see Blender is doing is it's sort of, it's subdividing this geometry and then smoothing it, right? So subdividing this would be the same as, you know, hitting subdivide here. What it does is it slices all of the quads into like 4 more quads, right? But the difference is with the modifier is that it also smooths the geometry out. So this sort of gives us like half of what we want, right? Like it's, instead of it being like this like mathematical edge here, like let me flat shade this, we now have like a smooth edge, but it's also like not the same shape. This is just completely wrong, right? What we can do is that because it's doing a subdivide of the polygon and then a smooth, what this means is that if we pack geometry tighter at this edge, the smoothing will be less pronounced at this edge, right? And I'll just show you what that looks like. If I just bevel this, immediately we see a tightening around this edge, right? And the reason that that's happening, if I apply this, is that there's more like faces in the center here. There's more geometry to get subdivided, so the effects of the smoothing are much less apparent. And this will keep stacking. This effect will keep stacking. If I add like a loop cut in the middle of here, we now have an edge that is like so tightly controlled that it is almost the same as what we had in the non-smoothed example. And this is how tightly packed like that geometry became across that edge. So ideally, we want to pack geometry in there, but in a way that's not, super tight, but that still pulls the creasing like into this central edge, right? And so now, if I want to have these sides and whatnot retain their shape, I can do the same again by like adding these loop cuts and then just positioning them in a way that mostly pulls the geometry back toward those edges. And so now we have sort of the standard low poly representation of this shape, and we have the hard surface high poly representation of this shape, right? So if I apply this and we have a look at the geometry, this is what we get. Okay. Now, hard surface for games can involve like a lot of hacks and cheats and tips and tricks that film might not necessarily want. Like this geometry for film, may or may not be fantastic because we're packing such tight geometry on this edge, and like typically, we want pretty even quads because this might be displaced, or there's like a lot more stringent requirements on things for film. But for games, like this is pretty good because ultimately we're going to be transferring all of this detail onto a low poly through like a bake. So this is like subdivision modeling. This is sort of the foundational like technique to achieving like your typical like hard surface shapes, right? So that's technique one. Actually, before I jump over, I'll give you some more examples, right? So if I take a cube and I smooth this, and the hotkey to just slap on a subdivision is Control 1, and Control 1, 2, 3, 4, 5, etc. If I want this to be more cube-like, right, I can run 3 cuts. I can select all of the cuts, and then I can bevel all of them. And now we've got like a cube, which has, and if I run some more in the centers, that'll give us a lot of supporting edges. So we now have like a cube that's mostly like smooth. But what if I then wanted to say extrude this inwards and then bring this out? We now have like a little bit of curvature here because we're not supporting these loops, like these edges with more loops, right? And then I can, as always, kind of like run more loops like this and bring that smoothing in to these edges if we wanted to. So this is like your foundational technique, subdivision modeling, right? This is kind of like hard surface 101, right? When all else fails, subdivision will work. It's just, it can be quite difficult to make certain shapes. You have to be quite knowledgeable on edge flow and topology, but this is your most foundational technique, right? So what we can also do instead of smoothing through using these edge loops, right, or controlling creasing, sorry, is that we can also control the creasing through bevels. And I kind of did that at the start of this video. So if I just quickly recreate this geometry, roughly approximately, add a modifier and type bevel. And then I can just manually control sort of the holding of the edges here, like the edge creasing here, and crank the surfaces up a bunch, something like that. And then if I want, I can turn harden normals on. That just guarantees that these flat edges retain their normals. And then smooth it. Well, these are similar results in that the outside edges here have tightened their smoothing, but this inner surface here is, it's tightening its smoothing in like the exact same way as the outside, whereas on this example, we've got like this nice sort of curve. So in a way, like you're trading sort of ease of use for control. You're like telling the modifier, hey, just like bevel my things for me, and you can sort it out. But ideally, like we want, the best of both of these worlds, right? So, and we can totally use these in conjunction with each other. So the way that we would do that is we turn limit method onto weight, right? And then we manually set the weights. So if I select an edge, we have over here in the items panel, you can set the bevel weight there, that way, and once you've set it, you get this sort of blue edge. Or in your Control E, edge menu, we have edge crease down here, and what we actually want is edge bevel weight here. And so what this is doing, if I go and select sort of all of these edges that I want to be like these tight edges, I can select all of them, and then through that menu select that button. And what I've gone and done is I basically told Blender only bevel these edges, like bevel by weight on these edges, right? And then what I can do is I can then add a subdivision modifier on top of that. So if I press Control 2, that's going to add a subdivision, and then I can get these edges again, Control E, grab these edges, bevel edge weight. And so now what we've gone and done is we've achieved a very similar shape to the original subdivision method, right? But by sort of using like a hybridized approach. We have a bevel modifier that is roughly controlling our overall shape, and then we have a subdivision modifier on top of that that is allowing us to get these like curves in here. And the cool thing about this is that these methods can be mixed and matched, right? Like if I decide that this curvature is a bit extreme, I can just add a control loop and pull this down or up, right? And so this method is more in line with how I tend to make a lot of my props, because it gives me the ability to sort of drastically make changes, right? If I take this prop here and I just rotate this piece over to the side, I can now give this like quite a wild sort of curve like this, and it holds all of its shapes very well. If I wanted to do that on this cube that has like edge loops, there's nothing stopping me, but I have to make very damn sure to grab like this support loop and bring that over with me, right? And then make sure I do all that there. So in this case, it works out fine, but do you notice how if I was to rotate this to a much more shallow angle like this is here, something like this, well now I've rotated this loop sort of with it, right? So there's this bit of a bend here, like this bit of curving, when in reality we don't want any curving at all. So I would now have to sort of counteract that more like that to get that sharper edge there and that more natural edge there. And there's no problem with that. It's just that, you know, the more and more you work, you might decide, actually, I want this edge here to be like a 45-degree chamfer, and I might want it to be a large chamfer. And what you can see is sort of all this geometry is sort of in the way. Whereas over here, all I need to do is chamfer this, and then remark some of these as sharp, down here, and then maybe just clean up some of the geometry, the extra geometry sort of that I've been given here. And so now I've been able to add this 45-degree bevel, whereas doing it here, like, it's not impossible, it's just a bit more work, right? So that's kind of the key takeaway here, is that there's not only one method, there's no one size fits all, and you're free to mix and match like the pros and cons of every like method, you know, to your liking, right? So that's method number 2. Now method number 3 is a little bit different. It involves stacking 2 different subdivision modifiers so that they can sort of smooth and then re-smooth, right? So I'll show you what this is now. If I pull this up and then just press Control 2 or Control 3, we get like this weird egg shape. But let's say I don't want this egg shape, I actually want like these sides to be solid. So I'll grab all of these, and then if I hit Control E to bring up the edge menu, we see this edge crease thing? Shift E. I'm going to use Shift E to edge crease that. What that's going to do is it's going to say that for the purposes of this subdivision modifier, if use creases are ticked, we want this edge to be like exactly perfect, I guess you could say. It also shows here, you can set the crease here, but Shift E is just a really nice hotkey. If I drag that all the way to finished, it's going to say like the verts that get subdivided between these 2 verts are going to stay exactly on this line, right? We'll do this one as well. Okay. drag that up. Cool. So, well, this sort of goes against like the point, right? Where did our nice edges go? I guess we've got this like nice control over this bent edge because like let's say we want that by design, but what about these solid edges? The idea here now is that we actually stack a second subdivision surface. And if we stack a second subdivision surface here that doesn't use creases, well now, do you see this here? It's going to try and start smoothing this out because it's going to subdivide this with like extra faces and then smooth. So by manipulating the subdivision count of the first modifier and then how smooth the second modifier is, we can change the tightness in the first modifier and the smoothness in the second modifier. So this can work really nice, but the main drawback with this is that we're trading poly count for ease of use. So if I start editing this, my computer's actually kind of lagging a little bit here when I start like working with this. When in reality, if I go in here and start moving this, it's like perfect, right? Like super fast frame rate. So this is another interesting technique that you know, it has its drawbacks. Like it's kind of terrible for your computer, I guess, in a way. But you know, it's quite easy and quite straightforward, and it sort of just works. So I would describe this as method number 3. So I've just cleaned up my viewport to sort of better illustrate the point between these methods, and then we'll go into method number 4. So method number 4 is quite simple, similar, to number 3, in that it sort of relies on an initial subdivision with creased edges. So I'm just going to copy this one, and then let's say if I just add some extra like geometry here, just to kind of, I don't know, make something interesting, make some interesting shapes. Like we'll say that, and then something like this, right? Okay, so we have this geometry, but again, we want back our nice like clean edges. So we've got our curves that we want from our hard surface, but we want these edges, these like smoothed edges. So this method is a little bit, again, it's another one of those like computationally expensive methods, but it's, you know, in exchange for computational intensity, you gain like ease of use, I guess you could say, right? So what we're going to do is, like, let's say we've modeled our object with creases and with subdivision. We're going to, and you don't have to apply this, but I'm going to apply it just like so I can stay clean. I'm going to, let me shade this flat so we can see the edges. Cool, so I've applied this geometry. Now what I'm going to do is add 2 extra modifiers. I'm going to add a remesh, right? Now what remesh is going to do is it's sort of like adding the double subdivision, right? But instead of doing it through a subdivision method, we're gonna do it through like a voxelization method, right? So I'm gonna say smooth shading, and I'm going to just mess with these settings to be roughly what I want. Yeah. Yeah, okay. We're going to make the voxels quite small. And again, the smaller the voxels, like the higher the poly count and the more intensive this is going to be, right? So this is sort of what we have. On top of the remesh, I'm now going to add a smooth corrective. And I'm going to say this smooth corrective is going to only smooth. Its smooth type is going to be length weight. And now we're going to start messing with the repetition count and the factor count. So I'm going to set the repetition count to 50 and just mess with the factor. And so you can kind of see like what the point of this is, right? A factor of 0 is going to be no smoothing, and then we start smoothing. So ideally we want it as smooth as we can, but we're sort of like getting these like blobby edges here. And the reason we're getting these blobby edges is because when this was voxelized, here, kind of picked like the kind of like terrible sort of topology to voxelize this with. But again, we can nuke this like just with more voxels. Do you see that? Bang! Like just crisped that edge right up, just by nuking it with polygons essentially. And let's have a look at what that geometry looks like. So you can see we've done something like very similar to number 3, but subtly different, right? They look very similar, but if we look at this edge flow, this is like following standard sort of edge flow. It's like wrapping around like the directions that it would wrap if it was smooth through subdivision. This doesn't. It doesn't follow like any sort of edge flow because it's based on like a voxelization structure to rebuild this mesh. Okay, well, why would you pick one or the other, right? So this one here is really good if you're using Booleans in your workflow, right? So, and I'll show you, for example, if I take this object, we'll delete these. Actually, I'll just move that off to the side. We'll take this object and we'll say what we're going to do is we're going to add a big like hole through the middle of this, and we're going to do it like right on the edge, or we'll do it. Actually, we're going to do this in the absolute worst position. We're going to do it like this, right? We're going to do a big hole cut that spans several like edges and several different types of shading. Get out of here. So this is like kind of a worst case scenario. So I'm going to add a Boolean modifier to this. I'm going to set it to exact, and I'm going to say use the cylinder. And this is the shape we're going to get, right? Actually, I'm going to do this with a much more dense cylinder. I'm going to say 64. Oh, sorry, my numpad's not on. Hide this, get rid of that. Cool. This is now our Boolean shape. So this is the type of cut we're going to machine into this. This is where this workflow becomes really powerful, because this is like a really wild shape, you know, with this like close little edge here to sort of, you know, cut in. Like running the edge loops for this with method 1, like it's totally possible. Nothing's impossible, but it would be like a nightmare. Running the bevels with method 2 might give us some really weird interpenetration and really weird shading issues, right? Method number 3 could work, but we'll try it, and I'll show you the difference. Method number 4 will work, but is computationally expensive, right? That's kind of the trade-off that we're making here. So I'm going to apply this. Oops, I'm not going to duplicate it. I'm going to apply it. I'm going to delete the old thing. And again, the way that we do this is we first add a remesh. And I think the value I used before was 0.02. We're going to add that, so our edges tighten up, and then we're going to have a smooth corrective. And we're going to smooth only, not bind coordinates. We're going to do length weight, and we're going to crank the repetition to about 50, and we're going to tighten the factor a little bit. Oh, sorry. Something like that, and then set this to smooth shaded. Should be smooth shaded. Where are you? There we go. So now we've got like, you know, pretty much the best of both worlds. We have all of our like edges like cut in here. We've made an incredibly complex shape in absolutely no time at all. But there are some legitimate drawbacks, right? So first of all, the try count on this is going to be massive, which again, not a problem because we're baking. But secondly, if you have these like 45-degree angles as like your geometry moves down a slope that's like against like sort of the grain, if you can imagine a voxel structure is like a digital checkerboard, well, this could be like quite annoying to get to shade like perfectly smooth. And the only real way to correct this is by just increasing poly count and messing with the smooth factor. So you've just got to kind of strike a balance between how much CPU you're willing to throw at this and how clean of a slope this needs to be. But that to me looks good enough, and this is going to like bake really well into like a video game, right? So that's sort of option 4. Just for completeness sake, I'm going to show like what option 3 looks like when we try and apply it to option 4, right? When we try and mix and match. So this was our Boolean geometry that we made, and it was subdivided first, and then Booleaned, and then following the logic for number 3, well, we just need to add a secondary subdivision modifier, like this. And we don't use creases, right? And then we crank the first one a few times. So following the logic, we should just be able to add another subdivision to this. Let's have a look at what happens without creases. This is sort of the problem, right? So when you Boolean things, the computer is just sort of left guessing about like what the topology, I'll just turn this off while we're looking, what the topology of this like should be. And we've got like, this is a massive n-gon here that's like really long and really weird. And then we've got another one down here and just a bunch of like weird geometry because that's what Booleans are doing, right? So this is why number 3 doesn't really hold up so well when you start doing like Booleans and intersections, right? Because you start getting, like again, it's controlled the smoothing like quite well on this top edge and this side edge. There's a bit of pinching here, but this is just unusable geometry, right? This would never work. So that's like what the strength of number 3 is. But like we saw before, right? Like on that slope, why did I remove this? Let me just add this again. Why not? For the sake of completeness, right? Remesh. Small voxel size, as small as you can go without butchering your computer. Smooth shading, smooth corrective, length weight, only smooth, a pretty high repeat count. Okay, so this looks great like for the Boolean, like if we compare them side by side. But again, we do start to see some inaccuracies on the slope here, right? So that's the key point with all these techniques is like there's no one way to do this. And these are only 4. I could think of like 2 or 3 more that I won't go into this video because we're kind of running a little over on time. But these are like the 4 major methods that you would use to control smoothing on a hard surface model. None of them are better or worse than any of the others, and you will end up mixing and matching most of them. Right? Like they are simply tools that you will use to create the shapes and geometries that you want. And we're going to look at a little bit more of that on this knife, right? So if I'm going to sit down and make this knife, I'm looking at this edge, all these edges, right? And I'm seeing like, okay, well, this could benefit very, very easily from just using a bevel modifier to like establish this large like outer area. Maybe creasing with like a little bit of like double modifiers here could hold this shape really well. And then we've got like in general we've got sort of these edges here, like these wider ones here, and this edge isn't perfect. It's got this like rounding to it. I could control these with edge loops, right? On the final shape, I'm seeing like, again, these like wide curvy shapes. That looks like we'll do some edge loop control there, so that's fine. But then we get these really tight edges. So, either creases or bevels in here. And then finally, we have this sort of like weird Boolean pattern in here. And modeling like the edge flow for this, like using just a standard subdivision technique would be a nightmare. So I'll end up finishing this off with like the remesh approach, right? So it's like we're going to mix and match like all of these techniques across this weapon. So yeah, again, I just want to iterate that point, like hammer that point home. None of these are better or worse than others, and there are other techniques out there. It's just that these are sort of the 4 major ones that I use because I've never really needed anything else to make the shapes that I need to make. Yeah, and we simply apply them as need be. Alright, so now I'm going to get into modeling like this knife edge, and we'll just, we'll put the techniques like through their paces. Alright, so getting into this for real now. I've got these 2 primary reference images, right? I've got a side-on one where, crucially, there's very little perspective. That's going to be key. You can do it, just from pure reference, but it's a lot harder. And then I've got just this kind of like, hero reference sort of looking image. So what I'm going to do is I'm going to try and make this knife in proportion to how it is in the real world in terms of scale. Right? So I did some Googling. I had a look at like this product page. And the blade's edge is going to be 9 inches, which I'm just going to assume is going to be sort of from the top of the hilt to the tip. And it doesn't have to be perfect, right? So I'm just going to type in the x-axis here, 9in. Cool. And that's going to be roughly the size of the blade. So now I know this box is exactly 9 inches on the x-axis, right? Because I typed that in. What I can now do is scale the reference so that it matches like that scale. And so now I know like, okay, everything's going to be in proportion. And it doesn't need to be, like, again, it's not scientific. It doesn't have to be scientific. It just needs to be sort of roughly real-world proportion because that's what your game engines are going to be proportioned to. So it's really good to work in that as a standard. Cool. I'm going to make sure this cube is centered along the axis, and then I'm going to cut it in half, first of all, and apply symmetry, so we don't have to make the whole thing twice, and make sure that's on the axis that I want. Cool. And now all I need to do is start blocking this dagger in. So what I like to do is just really take stock of the reference image here, and like look at all the landmarks, and just sort of like block it in as I see it. Not worrying about topology. I'm not worrying about like any of that kind of nonsense at the moment. I just need the design and the shape blocked in. And what I'm doing is I'm picking like this flat face here to primarily work on. And I'm just subdividing. I'm like throwing n-gons everywhere that I can. I don't care about any of that sort of stuff just at this moment. I'm just trying to get in the shapes that I overall need. Cool. And then, whoops. Now I'm going to assume, I believe, yeah, this tang runs down like the handle here. So we're actually going to trace the entire handle the whole way down. Yeah. And I'm going to do it like pretty like low poly, right? Like I don't care about getting too in depth at the moment. And then I'm just roughly tracing this in. It's mostly like to take stock of the design of the overall shape before really like getting into it. Cool. And I can in fact basically grab all that and just tap F. It's going to chuck like a big polygon on the whole thing. Cool. And then we have this blade edge here, which runs all the way down to here, and then is going to connect up to here in some fashion, which we can probably more precisely set up here, but we'll come back to this a little bit later. Okay. Yep, that goes there, that goes there. This looks actually to have an edge sort of here, I guess. Not entirely sure how that resolves, but we'll see in a bit. Yeah. Okay. So that's the rough overall shape of the tang blocked in. I've made sure so that we have this main kind of flat edge here. Like all of this is planar, or it should be. Yeah. I can press like SY followed by 0 if I want to scale that on 0 on the y-axis. And then we have the actual blade edge there. Now what I want to do as well is I want to basically take the entire outside of this and extrude it into the y-axis like this, but with clipping on mirror. So that way it's smushed in. Going to take all of this. Cool. Smush that in. And now I'm going to cap like the little bits that I'm sort of missing. I'm just going to double check the reference. Yeah, that should be up there. That makes sense. Cool, like that. And then over here. Cool. Now, because I've modeled this in a bit of a weird way, like the way I've sort of decided to do this, some of the geometry might be like flipped inside out. So I'll just quickly check for that as well. I'm going to quickly resolve that shape there. If I click up here and then go to face orientation, see this? And this has happened just because of like the way I've modeled it, but it's an easy fix, right? I'm going to select everything, hit F3, type flip, type recalc. Or I just type recalc because it shows up, recalculate outside. Shift N is your hotkey for that. So what that's going to do is it's going to do its best to kind of mathematically like determine the outside of the shape. I also saw a little bit of weirdness in here, but that's just from sitting so close to the x-axis. Cool. So this is the majority of the knife blade shape. Now I'm going to start actually like hard surfacing this in, and then doing like some of these little extra details here and tidying it up overall, right? So I'm going to start by marking edges that I know are for sure hard, like these here, and the back as well, like the entire back tang of this is going to be creased. Crease all of that. Oh, sorry, not crease. I'm going to bevel this. Yeah. And I'm trying my best. Like, I have some little extra plugins and paid add-ons and whatnot that I use to make this a little bit easier. But just to prove the concept works with just standard Blender, I'm going to do it just completely with, like, default. Like, this is a fresh install of 4.2. Cool. I'm actually going to turn that visualize inside off because it's getting a bit annoying. And I'm going to quickly chuck a metallic material on this. And I'm in material preview, like from shaded into material preview. Just so it's easier to sort of see, where are we? The metallic-y like nature. It's easier to see the normals. And now that I've marked in a few beveled edges, I'm going to add a bevel modifier. I'm going to crank the subdivision like a little bit. Cool. And then start looking through this. We also see that the middle needs to be marked, like because this holds a knife edge. So this needs to be beveled. And if I toggle the, yeah, we're catching it there, okay. Mirror on, mirror off. That's interesting. This edge should be beveled. Oh, sorry, I forgot to set it to weight. It was set to angled, so it was just trying its best to guess. We make sure to set this to weight. So now we're getting the edges like where we need them. Cool. How do we want to resolve this edge? This edge would actually open slightly down here where the serration ends, which is what we see. We see that there. So I'm actually going to bring that down. Just going to drag from that menu. It's just a little bit easier. Cool. Run a cut there, just so I have a little bit of supporting geometry. I'm going to run a cut up to here. Get rid of this. Okay. Cool. Now we also need, I believe, on what have we got here on the concept? This one here holds its edge pretty tight. The other one's going to get smoothed out here when we eventually like add our subsurf in. Cool. And now I'm going to start tidying up, not majorly, but a few of these like n-gons here. Just going to run a big cut through there. Cut through there. Oh, I should be pressing C when I do this actually. Just to make sure it really cuts like all the way through to the other side. So if I run like a knife cut here in orthographic to this edge, it's not actually going to slice to the spine. So what I need to do is run my knife cut and then tap C and then left click. And that's going to slice like kind of like through the object. And these don't have to be perfect. I'm just sort of getting this here now because I'm about to start smoothing this with a subdivision modifier. And n-gons don't really like play too well here. Okay, and so this is the whole tang. I'm also going to quickly just cut like sort of a bad circle in here. And this is going to sort of remind me like, hey, come back to this in a sec. Just going to leave that there so I know that there's a circle there and don't forget. Okay. This edge here should probably also chamfer, or bevel, sorry. Cool. And then I can get rid of that. Make sure that edge is mostly planar. It's going to be slightly off, but that's okay. Cool. And then this big n-gon here, I'm just going to resolve by running a cut, oops, sorry, against the spine like that. And then that lets me, does it dip in on this dagger? No, not really, but this part here dips in. So I'll run a cut there and then curve that back, curve that forward, more like that. So we get that sort of curve. We also see sort of like a slight outward curve here. So I'm going to curve that in like that. Yep. I'm still unsure about how to resolve this in a bit, but we'll get there. I think what happens is that this entire surface this entire front bit here is mostly planar, but that wouldn't really make sense. So I'm not sure. I might just even omit that detail for now because it's going to be a bit annoying to really get that in. We'll see how much it like impacts the final design, right? Cool. Yeah, I might just pop that out for now. We'll see. Cool. All right, so what I'm going to do now is quickly smooth this by Control 2, tapping Control 2, Control 3, and now we'll look at the shapes we get. So as you can see, the edges that are beveled here, like this edge here and this edge here, when I subdivide, it's going to hold those edges like really well, right? This bevel can probably even be slightly tighter. Where are we? If I turn that off, sometimes it's a bit finicky. I'll just type like 2 millimeters here, or we'll say 1.5 millimeters. Oh, 0.1.5 millimeters. Okay, so this is an incredibly small chamfer. So we'll say 0.75 millimeters, something like that, and then I'll put the smooth on. So we can see literally how like the edges we've marked as sharp, we're holding, and then everything else gets like nicely smoothed together. And if we shade this smooth, this is like, you know, it's really starting to actually look like the steel of a blade. And in material preview now, we can see that like we're starting to get like a nice, like we're holding up the skybox really well, like with the reflections. This part here is smoothing out. That wouldn't happen at all on the reference. So we'll mark that as bevel. And then we'll have a look here. So now this is where we start to see some, this is how I like to model. A lot of people probably, you know, aren't really okay with this, but I've never had a problem with it. But if I run a bevel crease there, I can force this edge to be pulled really tightly. Do you see that there? And because this side is planar, it's not going to show up in the shading at all. So instead of having to like really mess around with topology, this is where like just a kind of like a supporting bevel cut becomes like really useful. And we know for a fact that this entire surface is going to be planar, so we're not going to see like any shading errors rock up even at like the most extreme like angles, right? So it's not a problem at all. A lot of people probably aren't really okay with seeing topology like that, but it's genuinely fine. There's absolutely nothing wrong with it. The key reason though that there's nothing wrong with it is that this is a non-deforming, non-displacing mesh that's whole purpose is to have really good normals so that we can bake it down for a game. And so that's sort of like your little almost like your disclaimer there, right? Is that if you don't have to animate the topology, you can do a lot of kind of cheats with it. You know, you can really cheat and hack your way through it. Cool. This top one should also probably be creased. No, sorry. And again, normally I would use plugins that hotkey and all of this, but I really wanted to like set this up from the perspective of sort of someone who's fresh, I guess you could say. I'm actually going to camp for this one. Like, so this is a good example, right? On the reference, this rounds slightly, but on the left it seems to hold pretty tightly. Now this can just be the image, but for the sake of argument, I'm going to treat it as though this is a tight edge and this is a soft edge, right? I could leave it like this, like it kind of looks fine, but I don't know. It's not quite too faithful to the original design. My bevel's not going to hold it the way I want it to because it's too tight, right? So this is where we go back to the old subdivision technique. I can just increase more loops in here is going to allow for that shading to be tighter. And I can control how tight the shading is by widening the loops, right? So I can pop that in like that and then just literally eyeball this in until it looks more like what the reference is sort of asking for. Like that. See that there? Bada bing, bada boom, right? So what else have we got here? That one here, we'll bevel that. And if the edge is looking a bit weird, we could run a sort of supporting bevel out to here, but we don't have to. Cool. That's fine. This here, interesting case, I could probably just chuck just a straight end-on in here and then pull this back like this because these edges normally aren't flat. Normally they've got a little bit of curvature to them like that. Cool. I might want to make this edge planar if I'm going to try and do that. That whole edge probably runs flush, but due to the nature of the reference, it's probably slightly off. So I'm actually going to shift that up a little bit there. Cool. That back edge is probably flat. It's anyone's guess if this edge is flat. I think for this type of designed like knife, it's probably not. Okay. Now what I'm going to do is I'm going to duplicate this whole object and I'm going to shift it over. And I'm going to apply the mirror because we're now going to work on the handles. All right. So I've applied the mirror. The handle is going to basically be sort of the same shape but pushed out. Oh, actually, sorry, before we do that, I just realized I never really laid in the smoothing for this like handle bit here. So I'll do that now. And this is pretty simple. I just need to select like all of these edges and run a manual bevel there to tighten it. But I'm just going to flatten this back side out before I do that because I believe that from the perspective of like the reference image, that's probably like a flat edge there. Cool. And I'm going to make sure that all of these front edges here, where the fingers come out, they look roughly in line. It's kind of hard to tell. Maybe not. We'll just leave it for now then. This should definitely move up, like to accommodate now, because like we're still trying to model this detail here, but just shifted like up to where its natural position is. And I'm going to run bevels through these here. There'll be one more on the end on this one. Cool. And then we probably actually see not this shape here, but like an exact, almost like an exact mirroring of this. So I can do something kind of a little cheesy here. I'm going to select all of these, press Shift D and then Z to move this down. Then I'm going to press S followed by Z followed by -1. So what I've done is I've scaled it on Z by -1. I've flipped it, right? And because I've moved it straight down, I know for a fact it's like exactly in line with this. And I'm just going to put this here. And now I'm just going to like merge this geometry in. So I can delete these old faces. Move this up and over here. Put this in here. And just go to the work of merging all this in. Like that. Now the geometry is going to look a real bit scuffed here, but we'll deal with this in a second. That edge, this edge, this edge. Bevel way up. Where are you? Sorry, it just merges out there. There we go. Now this is one of the legitimate criticisms of using bevel, right? If the bevels are too close to each other, they kind of break. So you need to like position them in a way that's not busted. You also need to be weary of its models, of its face orientation. The face orientation controls how Blender tries to perform the bevel. So this is all broken because of that. So Shift N is our hotkey to fix that. That just like calculates all on the outside. And we'll fix this too while we're here actually. But we will first bevel this back edge here. Cool. Yeah, looking good. Now, because some of these edges here are a bit like tight and kind of scuffed, do you see what I just did there? How I said like remove doubles? And that sort of fixed it. What Blender's doing is that as these bevels get closer and closer and closer, it's trying not to overlap the result of the bevels. Like if you think about it, if this edge bevels and this edge bevels, they're going to like interpenetrate. And that setting is controlled down here, clamp overlap. So sometimes it's useful to leave this off and then just fix errors as they show up, like that there, rather than Blender, like trying to leave Blender to solve all the problems for you. Like sometimes it's better to just let it make the error, you know, and then we can fix it when we see it. Cool. Now I'm going to do this this properly, this hole properly, right? So I'm just going to select all of them. I'm going to hit Shift S and then select down and click. That's going to put my cursor here. Now if I add a circle with like, let's say 12 like verts, and I turn the clipping on my mirror off. Oh, it's already off, so that's good. I've added like a huge circle here. What I want to do is just rotate this into position. So I've rotated it 90 degrees and then I'm scaling it down, whoops, down to about there. Scale, 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 scale. I'm going to make this larger And the idea now is that we're going to merge these together just by like selecting random edges and hitting face. And then we're just going to like delete all of these extra like janky polygons here from the block in. So this is just like kind of like a a pretty roundabout way of putting a Boolean in here without using a Boolean, because if you want to apply the Booleans, you know, you can kind of butcher your geometry. And I think this is probably a little bit confusing for beginners. If I press Control X here to dissolve this, it's going to get rid of that vert. See that there? It's going to get rid of that vert. We can fix that by clicking Dissolve Verts here. Same thing over here. I probably want to cut that one in, dissolve this one, but without dissolving verts, and then dissolve this one. Now it's just a little bit cleaner, right? So I'm going to scale that into position. I'm going to hit F just to make a face, and then hit E to like extrude. Turn clipping back on, and then move that into position, right onto the spine. But I also want to get rid of this face. I don't want that face to be in there, right? So I'm going to delete that. So now, subdivision, this is where topology and these sorts of things come into play, right? Because these faces here, this like huge n-gon, is sort of struggling to subdivide this accurately. And if I chuck our wireframe on here, you can kind of see like the polygons are sort of like getting smushed over. We can fix this up by just making sure that this edge is like beveled. You know, we want that to be beveled there. So that's going to fix it in that way. And then we're going to add a bevel weight here. And that's going to act as like a supporting edge. But it's going to keep trying to do this. Do you see that? How it's like, well, it's still smushing it. It's now just not smushing it from this point. It's smushing it from this point. So if we just run a knife cut over to there, and the same thing like down here approximately, that's going to start like telling Blender, no, I want you to deform in like a way that's more conducive to my desires with this shape, right? In reality, we should probably run these loops the whole way through, right? So a simple way of just like fixing that would just be to knife cut, like from this point in to the spine, like that. Or what we can do is we can go into orthographic view and we can run the knife cut from a single vert and just tap C and then click. K, click C, click enter. And that's going to like slice it like onto the spine, and it's going to slice it in a way that's like perfectly perpendicular, right? So that's fine. We'll do that here. And we'll just fix that up here while we're here. Now the thing about this is that if we start modifying this shape up here, we've just got to remember to modify these as well. That should have been fixed. Cool. So now we've like sort of, we're still saying over here, we don't care about the shading. We don't care about the geometry. And if I apply the subdivision, I'll show you what it's doing here. A quick way to apply this entire stack is just to hit F3 and search for convert. And that'll show this mesh option, convert to mesh. Basically like applies it. This is what Blender is trying to do with the subdivided geometry. So again, this topology is like the stuff of nightmares. It's like dreadful. But it doesn't really impact us like shading, so we don't care, you know. If this was animating or deforming, this would be an entirely different question, and you should really go in and do like correct sub-D modeling to like make sure that your topo is going to work out really well. But as long as this shades correctly, that's all we need from this model. And if I turn off wireframe, it's going to illustrate that point like a little bit better. Cool. Okay, so now we could get back to the matter of beveling these primary edges out here. So we're just going to run a bevel like that. Boom. So now we have the geometry here that we need to actually support these like finger holds. Like that. And I'm just going to move them into a position that's more conducive to the reference. As well, remember, like we've got this point that's roughly on the reference, but the smoothed edges are going to run outside of this point, right? Because it's smoothing this point to this point. So the true polygons are actually down here. So you want to make sure to move this up so that the black lines here are in line with the reference. It's especially apparent here, right? Do you see how different that is? Boom, right there. Cool. Now, you know, you've got to make some judgment calls here, right? There's a bit of there's a bit of perspective imparted here. I can see that this edge is a bit perspectived, I should say. So I'm just going to leave that curvature there. But what you could do is you could subdivide this and really start controlling like exactly how the edge falls if you felt that the like the reference wasn't or the reference was more accurate, like maybe you were working from a mathematical blueprint, for instance. I'm just going to assume that that error is from perspective and just leave that there and just kind of go through and fix these up here. Cool. This one might actually need that. It seems like a little bit more of a complex shape. It's got more of a curve to it, maybe. Sort of hard to tell from the reference. I might just move this one into position here a little bit and then give this edge the same treatment that we gave to the top. Yep. Okay, how are we looking? That edge there is a lot tighter than in my reference here. So again, we just need to bevel this edge and ensure that we don't wreck like our existing beveling. We don't need this one here. So we're going to get rid of that. And we're just going to control our smoothing the old school classic like sub-D way, right? Because you can always rely back on your fundamentals. It's why you sort of need to learn like the fundamental techniques before you start getting into like cheating with these sort of geometric tricks and whatnot. You want to learn at least the basics of how subdivision works before you really start getting in and messing with stuff. Cool. I've just noticed that a few of the pieces here, a few of the verts, have kind of like fallen out of angle, I guess you could say. So I'm just pressing scale followed by shift Y. So that's saying scale on every axis that is not Y, and Y is this horizontal like deep axis, right? So I'm saying scale on every axis that isn't Y down to 0. It's just kind of smush them back together like on top of each other like that there, right? This edge probably comes in here. Same treatment, S, shift Y, 0. Same thing here, S, shift Y, 0.
Okay, sorry about that. My headset ran out of charge, so I had to swap microphones so I could continue. So let's just get back into it. We're going to work on these edges here. This is going to be a bit interesting. I just need a series of cuts for each one. They don't have to be perfect. We'll fix them up in a bit. And this is probably going to be a big combination of beveling and subdivision. All right, so I'm going to select through all of these, subdivide, and I'm not going to grab these down. I'm going to slide these down by double tapping G, and that allows us to keep our like exact silhouette. I'm going to start double tapping G and scaling these around so that they're exactly into position. And again, we've just got to kind of like eyeball this a little bit because the reference is like, you know, not perfect. I'm going to run this cut here and we'll say that's that one there. Cool. How am I going to resolve this? I'll try, if we turn all the modifiers back on, I might do an inset here and then delete this front face and try this, a shape like this. We'll just see how this resolves. Maybe get rid of that. Okay. It's kind of hard for me to exactly make out how this is supposed to look, so I might just fiddle with this for a little bit until I come up with something that I'm happy with. Yeah, okay. And then we'll need another bevel over that edge, I think. Yeah, okay, I think this is what I want to roll with. Whoops. If I move this up, because we're dealing at really small distances, do you see how it snaps like that? Mirrors, the distance on the merge for the mirror modifier is like really tight at the moment, so. This can probably come out a bit. Okay, that's roughly what we want. If we need slightly finer control, we can tighten the bevel here. Do you see that? How I'm, instead of leaving it to 1, I'm just going to leave it at 0.5. That there is probably going to give us exactly the serration that we want. So we're basically just going to repeat this process. So essentially, what we're going to do is cut in to the top line, and then we are going to run a couple cuts here and here, back down to this point, and then we're going to connect these, delete this interface, bevel of 0.5. We'll end up fixing this whole line as well by the time we're finished. But that there is about the way we're going to achieve this, I think. Yep. Alright, so now it's just a matter of repeating what we've already seen, right? We could do some fancy stuff with arrays and copy paste, but like, it's not going to be a problem. I'm just going to kind of, oops, just try and bang that out. We'll just do one more on that end, and we'll fix everything else in a bit. Okay, now we want the inside here, like that. Oops. It's a bit finicky in here. For context as well, I may as well show you the way that you could do this very quickly. After I finish it, I'll just go through and show you that at the very end there. Cool. So merge that together. Oops, no, this one to here, that to that. And I'm tapping J to like slice between active elements. But my computer's getting a little laggy here, so I'm just going to turn subdivision off so I get some speed. There we go. That's a lot nicer. Cool. Delete that. We want that. These. There we go. That's a little easier. Cool. 0.5. Now I'm going to grab all of these bottom, and I'm holding control so it's easy to like click between them all. And I'm going to just press G and then move them along Y. Like I'm going to smush them into the Y axis. We're going to turn the subdivision back on and take a look. Right, so now we're going to get to handling these details here. Right, what I'm going to do is I'm just going to run a cut, and I'm making sure to tap C so that I slice the spine. Well, for some reason it didn't slice it there, so I'll just slice that one manually, scale Y by 0. Okay. So now this is going to let me kind of cheat a little bit. Let me just turn the subdivision off there so my computer's a little bit faster. I can now run an edge loop like within the confines of this box. And what I want to do is I want to run one for each dip and center of these nubs, right? So I want to run 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so I can just block it in and then type 11 cuts. Scale them on X so that they roughly match where it looks like it should go on the reference. Do you see that? It's like one in the dip and one on the top. Now the reference may not be perfect here, but when they machined this, it was probably, you know, CAD data. It was probably machined like very, very precisely. So I probably should have made sure that they were all straight when I did that. But if I set this to individual origins, I can just scale Shift Z. So scale on every axis that isn't up and down by 0. And that's going to flatten them all down if they're all on individual origins. Cool, so now what I want to do is I want to move all of these edges down. These ones, like this, right? I also want to run a bevel on them to flatten them out. Oh, that's a bit of an interesting edge there. Making sure on individual origins, I will scale horizontally like this to sort of flatten them out to match the concept. If this was on median point, they would like get larger, right? So we want to scale each individually selected thing using individual origins, like that. And now I'm going to do the exact same thing for the peaks, right? So I'm just going to do a little tiny bevel, because if I do a big bevel, it's going to bring it all the way down. And I don't want that. I just want to do a little bit of a tiny bevel, just to lay the geometry in. And now I can scale on X to like thicken that up. Cool. Yeah, I probably should have made sure that when I laid that initial box in, these were all straight. So now I'm just going to go through and make sure that all of these are flat on the X-axis. So it's not a huge time waster, but probably should have done it properly, right, the first time. So I just need to select them all with holding Alt to get the loops. Make sure that I'm in individual origins. Scale X 0. It's going to flatten them all out along the horizontal axis. Cool. Now back on median point, I want to grab all of these to scale these to 0 on Z. I'm going to grab all of the top. I'll do it in vert mode actually. Cool. Flatten them out. So now that's done, but this is probably going to smooth a little weird. So we'll just turn subdivision back on. Yeah, do you see that? Like, we're pretty liberal with a lot of our topology when doing like some stuff like this, but this is just not acceptable because it completely breaks the shading, and we're only here to make sure our shading's good, right? So that's like rule number 1, I guess, or well, one of the rules anyway, but definitely can't allow for that. So what's happening is that we know this huge n-gon is sort of being like smoothed around and smushed around this shape. So it's a relatively easy fix. We just need to run like edge cuts off onto other geometry to sort of force it to not try and subdivide it in that way. And that's it. So now instead of sort of the central point, like if I apply that, instead of this central massive thing being up here and causing the shading errors, because we ran the cuts like this, it sort of forced the average down here. Okay. Now you can leave all this geometry here if you want, or you can sort of like try and get rid of some of it. I'm going to try and maybe get rid of some of them. See if it's worth doing, you know. You don't have to. It can just make working with it a little bit easier, a little easier to select. And the normals again look fine. Now we need to make sure that the bumps on all of these have bevels. Cool. I mean, I'm sort of splitting hairs at this point. I probably should have just left the geometry there. Don't break what's not broken, right? So I'm going to leave that there. Cool. What else have we got? Just checking for the normals, make sure everything looks good. Does this look like a knife? Does it shade correctly? We see a bit of a shading error there. Do you see that? So again, we just want to run a piece of geometry out to the side that prevents the triangulation of this n-gon in a problematic way. Pretty straightforward. Cool. So, what else have we got? We've got a piece of detail out here. These again are probably like similar to those sort of nubs we blocked in before. So on all the raised edges, I'm going to run supporting loop there. Sorry, not a supporting loop. I'm going to run bevels. Drop these in. Maybe straighten these up. These wouldn't be like so lopsided. Yeah, something like that. That's probably where the user's thumb is supposed to grip onto. Cool. Now I'm going to make sure, double check these. These look good. We could maybe split hairs over this. Yeah, that looks fine. And we're just going to assume that discrepancy is due to perspective. Cool. So now we're going to work on the handle. This all looks mostly good. Yes, this is all good. We're now going to work on the handle. This like knife blade handle here. So basically I'm just going to duplicate the whole thing over, and I'm going to delete all the geometry that I don't need. Right, which is basically all of this. Before I do that, I'm just going to run a big slice with a knife straight through this using C, so it runs to the spine. I'm then going to bevel it, and then press X followed by F. And that's basically just an easy way of like putting a break in the geometry. So now I can click any one of these elements and like mouse over it and just tap L. It's going to grab the entire element. Now it's really easy to delete everything that's not the handle, right? So, well, now we need to essentially run this geometry into here and there, and we need to rebevel this. Cool. I might just quickly run a loop. Cut across there, cut across there. Now this shape is going to be a bit more interesting. We're not going to be, because this is not flat like this knife blade is, we're not going to be able to be so cavalier about the topology. We're actually going to have to pay a little bit more attention to this one. So what we need, something like this. And like this. And what I've realized as well, we've still got our mirror modifier on here. So what we're actually going to do is just get rid of that real quick. We basically want to literally just get rid of the mirror modifier. And I'm going to just select this entire thing. Or maybe not the entire thing, because we've got this here. How do we want to do this? Grab these up to that point, then grab these right there, grab these there. Now we can grab this F, and I am going to grab all of this and mark this with a bevel. So we've just forced like the entire back side to be flat, essentially, is what we've done. We've said you're just going to hold your back edge there, and then I'm going to turn subdivision back on. We get some errors. These are not visible. These aren't going to be baked. So we're just going to ignore them. They're not a problem. Cool. Now we're going to start laying in some of this detail. And again, my computer's lagging a little bit. So I'm just going to drop some of that back down just so I can see what's happening. Now, if we look at the other reference, we see that this is overall like a curved surface. And we've got a few interesting like sort of pieces of geometry here that we're going to have to like support, right? There's this like kind of like cut that runs across the whole thing. So this is going to be probably a little difficult to do, but not, you know, not impossible. Nothing's impossible. So, whoops, drag that into here. If I apply the location of this, right, when we made the blade was centered at the y-axis. So if I apply the location, it's going to slap the location all the way to the world origin, which means that now mirrors along the y-axis are going to snap all the way to the other side, and we can start to see the handle of this is going to start to like take shape. And the only important thing we need to realize is that eventually this subdivision amount and this subdivision amount will need to match. And that'll give us like that nice like edge there between the two. But for now, we're going to leave that off. Not off, sorry. We still need like 1 so that we can see what we're doing. Okay, so looking at the reference, we're going to see what looks to be... Yeah, there's an extrusion up, and then there's our chamfered edge here. Right, so I'm going to grab the entire thing. Grab that whole backside. And run an extrusion. And then pull the whole thing back. Like this. And then I'm going to double check. Turn that mirror modifier off. We don't need that yet. It should have preserved most of our edges. Except for these ones. Yep. Actually, I don't know if it preserves any edges. Whoops. Cool. That's mostly good. Now, we have to work on bringing some of these in, like this. And because we've got our edge like already creased, we can start to see this bevel like come in as we see on the reference. The thing is though, the overall beveling on this, because it's a piece of plastic, we might even want to like drop this down to like 0.50 millimeters or something like that. You don't want it to be too tight because you need the detail to show up like when you eventually bake the thing, you know? So it's just like striking a balance between those two. Cool. Now this entire shape is not flat on this front either. It's going to bend back. These shapes. Ah, yeah, there we go. Knife cut straight through. Pull the back completely off. Fix the hole. Add the bevels. Cool. Straighten that line up, and then we can get back into blocking in this back detail. Completely forgot about that piece that comes off there. Cool. And I'm going to, just like up front, I'm going to bevel this a bit. Sorry, I'm going to chamfer that and then bevel that. Cool. Pull that in. Okay, now my computer's got... Yeah, sometimes when I move it, it lags, and then other times it doesn't. So I'm not sure what is happening there. Maybe some OBS weirdness. Pull that up. To about there. Cool. We see some weirdness on the backside. I'm actually just going to delete that face for now while I'm working, and I'll be able to finish that up at the end. Cool. Crack the subdivisions a little bit to see how the finger grooves are holding. It's looking okay. Where do we want that one there? Now I'm gonna click the far back one and the far front vert and just hit J. I'm gonna try it here, but I don't think it's gonna. Yeah, no, we're gonna slice through. So we'll just have to do it a little bit manually with the knife tool. Oops. I'm gonna clear this content out from the middle, making sure we don't lose any of the bevels we need. Cool. We'll get to fixing that bit in a little bit. Because what I want to do is I want to make sure there's enough geometry here to support an overall bend. Because we need a bend in this. I'm actually going to try and symmetrize a lot of the finger details. So get rid of this here. And at this point, I'm sort of assuming like, well, look, what's more correct, right? The reference or, you know, intuition? And we'll have to fix up some of the blade material, like the metal as well, because now that will have fallen slightly out of sync with that, but that's not a problem. Okay. That's for a pinky, so it probably doesn't align too much with the rest of the blade. Okay, so we've got that there. Should bring that up to the middle. May as well run the whole thing. Run this one down to here. So I'm just sort of prepping this in a much more like mostly grid-like fashion. And this is much more sort of stock standard topology rather than pulling like a lot of that kind of nonsense that we did on the blade. These as well, if I guess correctly, are more close, like they're a tighter detail downward. More like that, I think. So they're kind of tighter on the finger bits, and they're a little bit more, maybe more of a flourish on the front. Cool. Now the interesting part, we have to bend this. So we're just going to do it manually, and we're just going to see how it turns out. But before I do that, I'm going to chuck one more in the middle. And scale the middle out slightly, so that I get the bends back on the... I'll do it from the edges, actually. I should keep the interior geometry the same. Whoops. Yeah, something like that. Alright, now we're going to try and bend this. Before I do this, I'm just going to duplicate the whole thing and move it down, just to make a copy, in case I'm not happy with what I get. Oh, we've also put a little bit of distortion into here, so we'll just scale that and fix that up. Cool. And because we've sort of laid these like long cuts down the length of the blade... Oh, what have I done here? Get out of there. We should largely be able to just sort of push and pull some of this out. Except for the finger grooves. They're going to need a little bit more manual adjustment. They're going to be a bit annoying. So that's alright. Cool. Grab that out. I'm going to pull these in. Cool. Now you can kind of see how that's like bulging, like pillowing like a little bit. And that's because those, you know, they're perfectly up and down this loop. Really, they should be coming at an angle, like alongside the knife, right? So if I put my cursor here, and grab this whole edge, and do by 3D cursor, I can now bend that, like rotate that out. I can do the same here. But this might not actually be what we want. It might end up shifting stuff down a little bit. I mean, look, that's mostly fun. That looks like a bend to me, as far as I'm concerned. Now let's have a look at the smoothing. How is that smoothing? It's a bit janky. I'm not so sure I like it too much. Yeah, I don't really think that's acceptable. We might try doing this with a modifier instead, because then it'll be automatic. Right, so what's really good is that before we made a copy of our like handle here, right? So that just allows us to basically like get rid of the old one, get the get rid of the bent one we made, get the new one in, and just get right back to work, right? There are a few little bits and bobs that I need to fix up that I already fixed up on the previous one. So I'm just going to quickly grab those. Cool. Now, in Blender, we have something called the Simple Deform modifier. Simple Deform. This lets us do, you know, things like twists, tapers, bends, and stretches. So I should be able to just click bend and then crank it. Yeah, so what it's doing here is it's saying down the x-axis, we want to bend the verts around, and it's doing its best to bend them sort of around, if you can kind of imagine this like pivot point in a way. So if I was to shift this whole thing down, you can sort of see how I'm starting to position it like in the middle. Yeah. And when these 2 points here on the left line up vertically, we know that that's the center. Right? So now we obviously don't want like a crazy huge bend. And because of the way that we're doing this bend, we're going to have to counteract like some of this detail ourselves. Right? Because we went through all this effort to position the knife blade. This is kind of why I tried to do it the more manual way, but this will work. What we can do now is effectively start like bringing, whoops, sorry, bits of this geometry kind of back like into line. So like if we're sort of messing with the original underlying verts here, to ensure that the Simple Deform verts bend into the correct position, if that makes sense. Something like that. And then I can go out of my way to sort of impart, like instead of allowing this sort of horizontal, like this angle here, I can scale these verts up in the original, and that will like counteract that. So this is sort of why I was like hoping to make it the normal way first, but this will also work. Yeah. We'll make sure that the pivot point is exactly centered around like the middle of the blade here. And that's going to mean that the bending is going to occur like in the middle. Cool. That's a little bit more reasonable. This is holding a crease here because of the back spine and it being previously beveled. So we could delete the spine here, and it's probably just going to be fine, right? Like if I just dissolve that, we're now all good on that back edge. Whoops. Cool. That's looking nice up there. Cool. So that's starting to look oops, let me get rid of that. Starting to look like a knife handle. Now, because we've messed with the pivot point a whole bunch, and we've moved it over, we lose the ease of symmetry that we had before. Like this, right? If I want to mirror this on Y, now it's kind of mirrored on itself. But what I can do is I can supply an object instead. I can say mirror by the object, which is the central, like, blade. And now when I move this out, it doesn't sort of matter what the local rotation or position is. It's going to mirror, like, across the blade like that. Cool. So now this is going to get like a much nicer set of normals over it than like this one. Like you can sort of see the difference here. So sometimes it can be really worth it to actually like go the extra mile and make sure that you get like a much cleaner result with your like bends and whatnot. There's still a bit of like normal jankiness in there, and that's due to the order. So if I'm simple deforming before the subdivision, then it's like I'm deforming with less resolution. So if I move it after, it'll fix that up. Oopsie daisy. Sorry, I'm getting a bit confused there because I've got these old pieces here. I'm just going to move them way out of the way. Okay. So that's starting to look nice there. I'm just going to take a moment to sort of correct some of this geometry that was a little bit different now, because the two pieces are different. And I'm going to put a back on this real quick. I'm going to try and do it in a way that's not like going to take 10 years, but will ultimately support the shading of the underlying shape. So where is it? If I grab that to there, it's that one to that one, that one to that one. Yeah, we'll do these as well. That should be enough for the subdivision to hold. Cool. And all we need is for the edge to be supported, right? It doesn't need to be like perfect, you know, it just needs to be good enough. So just tweaking to make sure that this is mostly in line. Cool. A little bit more here. There we go. Cool, and so now we have a handle that is pretty crisp in terms of its normals and has like the bend that we see in the reference. Now we've got some more interesting bits, because this is going to start to get a little annoying to actually work with in terms of like beveling and whatnot, and trying to keep all the geometry like straight and perfect, especially when we get into these details. So this is where I would prefer to handle this with like a remesh, like a bevel and a remesh. Sorry, a Boolean and a remesh. So I'll do that. I'll do that now, and this will require a little bit of experimentation to get right. So I'm going to start by making this shape. Like so. Just a rough approximation. Again, perspective is going to be quite... It's going to run a little bit wild on these shapes, probably. Cool. There we go. So what was happening there when I tried to extrude these out is that it was really struggling to get any distance, and the reason was because it's got a very small scale. So I made sure to apply the scale, and now when I extrude, it's much faster because it, you know, sort of assumes it's at real world or at reasonable scales, not necessarily real world scales, but at reasonable scales. Okay, so we see these little things on the inside, I think might match, or it doesn't. It's kind of hard to tell if this is, you know, a bit more artistic and a bit more organic. So we'll keep everything in line. We'll roughly match the reference. I think maybe those run out more. Cool. Now what I'm going to do is I'm just going to do a little bit of measuring, and I'm just going to kind of see how this matches up to the design. So, you know, it's not... It doesn't appear to be the same shape necessarily. Copying and pasting across there. But it mostly is like this. So I think for now it's just going to be fine. Cool. Something like that. Yeah. Okay. So those are all the elements there that we're going to use to sort of slice out of this main one. Right. I'm going to do some duplication up top, just so I've got them sort of in case I need them again. I'll move them over to the side. And I'm going to try and cheat. Adding all of these as booleans one by one would be a little bit annoying, so I'm going to merge them all into the one object. Grab our mesh. I'm going to turn the mirror off while we do this. And I'm going to add a boolean. Now there's different add-ons you can use to make this like faster. Some are in Blender by default, but I'm just going to do it manually so you can see like all of the individual steps, right? So I've added a Boolean modifier. I'm making sure it's on difference. And I'm going to say we're going to use the difference of this object and this object. It's basically going to subtract this object from this one, right? So I'm going to use the eyedropper to select our Boolean shape. It's going to lag for a little bit because Booleans can be like a bit expensive. And this is the shape we get out, right? This is our Boolean. But this is a little bit annoying to work with, right? Like these are all sort of in the way. We can alleviate this a little bit by going into object and setting it to draw as wireframe. That's going to just like make it slightly easier to see. I'm going to call this like bool handle cuts. Something like that. Cool. And then we move this out a little bit. So what I'm noticing here is that these cuts probably occurred. We could probably set this up so that it was before the Simple Deform, if that makes sense. So we want to do more like a cut like that, so that it's about, you know, so deep. And it's going to like really lag when you're moving these around. It's one of the drawbacks of using Booleans. And then I'm going to move that above and then turn the Simple Deform back on. So now it's going to bend into shape with the Boolean like imparted on it, right? Cool. Yep. So now we see like a slight inaccuracy, but you know, as far as I'm concerned, that roughly looks like the reference. That'll be fine. Cool. So that looks good to me. Now we're going to cut these three, like we're going to do the same thing with 3 more Booleans for these central like screws, basically. So I'm going to measure out a cylinder. And because I'm Booleaning this after all of my initial modeling, I want these to be kind of high in terms of like poly count. So I'm just going to make them like 64 segment cylinders. That's going to be plenty. They just can't be something small like 12, you know? Cool. I'm going to make sure that this is, in the middle of the y-axis. Yep, there we go. And I'm going to duplicate these across. And I'm just going to, again, sort of assume that perspective is maybe bending that a little bit. Like I think that when they made this, they probably machined it in 3 solid groups. So we're going to have, these are going to be Booleans that cut. And I'm going to use the exact same diameters again, like the same dimensions. And I'm just going to duplicate these over. These are going to be screws. So if you can imagine, we're just going to like, once we've cut the holes, we're just going to put these little screws here, right? So I'm going to leave them there for now, but I'm going to hide them with a H, just to hide those. And now I'm going to Boolean these into this object. I'm going to try the trick as before, where I merge them all together just so it's easier, just so I can add like 1 Boolean. Now with this one, we want to do it after the deform, right? These were probably drilled like after it was, like, I guess, well, with their shape, they didn't make it in this way, but we don't want the holes to bend and stretch with the deform. We just want to punch a hole straight through, right? Cool. So we're going to say we want an exact Boolean. We want to use these cylinders and we want to check, and that's perfect, right? That's exactly what we want. I'm going to call this bool handle screws. And what I'm going to do is just select both of these Boolean shapes and then select this, and I'm going to hit Control P and keep transform. I'm going to parent these together. That's going to allow me later, if need be, I can move this whole handle up. And it's still going to lag because it's trying to redo the Boolean, but it's going to pull all the cutters with it, right? So no matter where I move this handle from now on, it's just going to be fine, you know? Just a little bit of ease of use. And then I will, of course, turn these back on to wire. Cool. So I'm going to take these Booleans and I'm going to move them onto a new layer. And I'm going to call this cutters. So these are like the Boolean shapes that are going to cut through. And that allows me, if I hit 1 and 2, I can just toggle back to my knife, leaving those behind. Move these screws in. I'm just going to do something. Yep. So what I can do is I can select all of these screws. I can select one master screw and then sort of hit Control, or is it, Control L? Yeah, so Control L will link the object data. I can click Link Object Data. And what that means is that when I change this screw, they're all going to change. So that just sort of lets me like set this up a little bit nicer. So I just only need to work on like one screw shape. Looking at the reference, we see that these are inset slightly with like a hexagonal pattern in the middle. And they've got a bit of a curve to it as well. So we're going to inset them a little bit. Oops, sorry. Something like that. We know that there's a bit of a curve to it. Not so much. And I am going to, again, use Booleans to punch a hexagonal shape into this. Like so, right? Now this one I'm not going to bother like keeping around. I'm just going to punch the hole and immediately apply it. It's just easier than like modeling that in with like cuts, you know? Just allows me to punch it in. That also broke the link across these, because when you apply modifiers it breaks the link, but we can just rebuild that link by selecting them and hitting Link Object Data. Cool. Now with this one, I'm going to position this edge loop so that it's roughly sort of in the middle of these two, and then I'm going to bevel it I'm going to turn clamp overlaps on, and I'm going to crank the amount of beveling that I give it. That's just the easy way to sort of get our like curved edge roughly. I can really exaggerate this. Like if I scale that up and move this over, and now try it again, I can kind of mess with the like the overall curvature, right? So something like that's good. Because I had clamp overlap on and I sent it all the way to the edges, there's now a bunch of overlapping verts here. So I'm going to select everything and go merge by distance. And that's going to say down here, remove 64 verts. It's just going to make sure there's no junk floating around out there. I'm going to smooth it as well, auto smooth it. So I get these nice like hard edges here. Cool. And those are essentially our screws done. Give these another metallic material. Sorry, I'm just going to call this metal. And so now we're starting to get all of the pieces of our knife really in. We've got our blade that looks good. It's subdivided with curvature. It holds its serration. The back is mostly good. We see some normal errors here because I wasn't really paying too much attention. Oh, sorry, this was actually because I tried to get rid of the geometry. Sometimes it's better to not even bother trying to be smarter than you need to be. Just get it working and call it done, essentially. Yeah, looks good to me. Cool, and then we have that. We have our handle sort of blocked in. I'm now going to also, actually no, I'll do the mirror at the end. We'll call the mirror at the end then. So we've got our handle here. I think that this is pretty good. This is good enough as far as I'm concerned. I'm gonna not have such a mirror polish on the metallic surface here. Drop it down a little bit. Maybe change, maybe add some lighting in here. Area light. I just realized the area lights aren't going to do anything for material preview, but we can change like our skybox. Yeah, that's probably a little bit better. Yeah. Looking pretty good. So we now need to finish off this piece, right? And so what I'm going to do is, again, I'm going to make a copy of all of this because I want this handle, like I want to keep a copy of it. I'm just going to move it all the way down. I'm going to input those commands. It's going to lag for a little bit because it's got like cutters and that sort of thing in these booleans here, so it's just going to lag out a bit. Cool, so that's down there now. I'm going to apply all of this. I'm going to collapse all of this down, convert to mesh, just like that. And then I'm going to delete all of these. And this is our pre-remesh mesh. I could probably get away, actually. Yeah, I'm going to undo this. I'm going to get rid of the bevel, because we're going to get the bevels in here by default anyway. Oopsie daisy. Yep. I'm going to get rid of the bevel modifier because those are going to return once we get back to this. And I'm going to tell the subdivision to use my creases. But the funny thing is here, I didn't actually use creases. I used bevels, right? So, well, how can I don't want to go through and crease all this manually. If I select one of these, I can do select by trait. Select all by trait. Where are we? Select by similar bevel. So I'm saying select every edge that had a similar bevel value to this edge. Now I can just crease this. Cool. And let me turn off here. If we go shade auto smooth. There. So what that's gone and done now is it's turned all of my previously like beveled edges into just simple crease edges. Because now we're going to remesh this whole thing anyway, right? So convert to mesh to bake all that down. Delete these cutters because we don't need them anymore. This is now just like true mesh. Cool. And this is our mesh with its booleans and whatnot in it. Now we do remesh. And we go as small as we possibly can. As small as our computer will handle, right? I'm just going to keep chucking zeros in front of this until it kind of can handle it. We'll say 0.001. Yeah, there we go. So this is like 4 million polys just on this here. I'm going to save a copy and then smooth corrective. Corrective smooth. We want smooth shading up here. Only smooth. 50 repetitions. Cool. And now we have our handle done, all with our nice chamfers, with our edges sorted. And that'll bake down to a normal map really well. And so that's like, you know, that's a pretty complex sort of shape to get perfect with the bend with subdivision. Whereas just doing a remesh with a smooth corrective is just going to handle that, right? So, what else have we got here? I just want to make sure that we're previewing that there in a way that looks accurate. I'm now going to apply this, so convert to mesh. Cool. Chuck a mirror on this along the y-axis by object. And we now essentially have, oh, sorry, we should also, I might just merge all these down. This will also just need, these will need a quick bevel. So all of these should be beveled. Mean bevel weight 1. I probably shouldn't have applied all these down, but it is what it is. Grab all of these. Cool. Bevel modifier, really small amount, 0.1 millimeters. There we go. Bunch of divisions there. Shading, hard normals. That then now catches light a little bit better. It can be slightly bigger than 0.01. Again, like, you don't want to represent, it doesn't need to be realistic per se. It just needs to, like, work visually. It needs to show up on a normal map, essentially. Cool. This knife edge might be a little wide, so maybe we shrink this in a little bit and then move the handles into to compensate maybe. Chuck a mirror down here. Again, we want a mirror on the knife and we want to do it on Y only, not Y and X. I don't know if that's accurate to the backside of the knife, but I mean, it looks like a knife to me, right? And then I'm just going to quickly give this some extra materials. So handle black or handle plastic. This is not metallic at all. It's a little rough and mostly dark, mostly sort of black. Then we have the knife edge. So knife edge. This is, it's anodized, I believe. Yeah, it looks like it's maybe anodized or something. A little bit of roughness. And the only point of these materials, by the way, is just so that we can see, like, the object. These aren't actually going to go, like, into the video game. We're not going to use them for this purpose. Something like that. It's mostly just so we can see the normals, make sure that they look good. And that there is essentially our finished knife. I'm going to move all of this extra stuff. I'm going to unhide, sorry. And then I'm going to move all of this extra stuff into a new material collection. Just call it junk. I'm going to call this collection, actually I'll leave it where it is. I'll move everything here into knife. Move knife second to the top. So we now have knife. And what this means is that we can add a new collection instance, knife. And this just allows us to move the overall knife and like pose it. It's just easier to use, and it's very quick as well. See how fast this is? Rather than trying to like move this object around, like maybe if it's still got modifiers, like if I drag this here, it's quite laggy. I'll drag it down to center it with like the x-axis. Oops. That there is essentially the middle of our knife. And we now have this here. So this, you know, this is good enough to now actually turn into a game res object through baking. I won't go into that in this video, but this basically represents all of the details that we would want baked down, and then we could take this into Substance Painter and actually start like texturing this PBR asset, you know? If this was Unreal with Nano, you could do things slightly differently, right? Like what you could actually do is sort of, you know, you could handle you could handle the handle in the way that we've done it, and then sort of either, you know, after the bevel, go through and actually retopo this manually so that it holds like quads mostly, or you could even just decimate this back down. Unreal's Nanite will handle both, but this here would be a perfect asset to actually bake from a high poly down to a low poly, because this is 9 million triangles, right? Like if you're using Unity or a different, you know, in-house engine, or just doing old school rendering, yeah, you want to reduce those triangles as much as possible. So yeah, I guess now at this point, you know, you just, if you want, like a few like beauty shots, just so you can see the edges, like check all the normals, that looks good. But this is effectively, yeah, perfectly good high poly model to start retopoing and baking from. Yeah, I hope this tutorial has like helped you in some way. Feel free to comment like suggestions if there's any other subject matters that you want to see tackled. I will go through and do a low poly retopo baking video at some point, but this is just like the fundamentals of like simple high poly modeling and just the different ways you could like achieve different results. Yeah. All right, awesome. Thanks for watching.